Well, good morning, everybody. Good afternoon, good evening, good night, if you're listening to this in whichever time zone. Welcome across the globe to FlightGlobal's second in our series of 4 webinars focusing on the crucial topic of aviation sustainability. The title of today's event is Hydrogen and Electrics, the Great Disruptive Propulsion Debate. My name is Mark Pilling and I'm the consulting editor at FlightGlobal. And we're partnering on this webinar with Pratt Whitney, an industry giant hell-bent on delivering the best engine technology for today's airliners. And I can't wait to hear from Michael Winter on what Pratt Whitney's vision is for delivering the power plants of tomorrow, however they are fueled. Now, we welcome questions from you, our audience. Please post them on the Q&A tab on the icon down there, and we'll try to answer as many of those as we go along and at the end. Now, to our expert panel. I'm delighted to welcome 4 people across the globe, 2 in the States, 2 in Europe today, who are at the very sharp end of designing, discovering, and delivering disruptive propulsion. I'm delighted that we've got Andreas Ax, the Chief Executive of Widerøe Zero and Head of Strategy at this Norwegian airline. Welcome, Andreas. Nice to have you.
Thank you very much.
We've also got an entrepreneur in this space, a real pioneer. We've got Joseph Callow, the co-founder and Chief Executive of Germany's H2Fly. Joseph, thanks for joining us. We've got Nikhil Sachdeva. He's the global lead for sustainable aviation at Roland Berger. Great to have you, Nikhil. And as I mentioned, we've got Dr. Michael Winter. He's a senior fellow, advanced technology at Pratt Whitney. Welcome, Michael, as well. Welcome, Nikhil. Welcome to everybody. Really looking forward to today's debate. Now, we're going to contemplate power, because if there's one thing that unites every one of you and many of us who are writing and delivering and whatever about sustainability, it's delivering those products to meet our industry's net zero greenhouse gas emissions targets by 2050, or actually, come on, before. But engines, I think you all agree here, ladies and gentlemen, are the key. But not only are they key to delivering zero emissions, we'd also like, please, Michael, a 20% rise in fuel efficiency along the way compared to current generation engines, right? Tall order, but it's something that the industry is asking for. Andreas definitely wants 20% or more. Now, as I wrote in a feature in my last issue of Flight International, I talked to many of you people, engine manufacturers, other people in this part of the world. We hear that hydrogen is kind of, if we'd be forgiven for believing it's already the solution. It's in our grasp, it's here. Is it? I don't know. We're going to talk about that, but there are power choices. We've got electric, we've got hybrid electric, we've got hydrogen. And of course, there's the faithful gas turbine. We're not going to forget about that. Michael won't let us forget about that, and nor should we. Our job is to examine all these choices. Okay, that's enough of the preamble. I'm going to kick off by getting Dr. Michael Winter at Pratt, to tell us, from an engine major's point of view, what is your roadmap? What do you see in a nutshell here, Michael?
Thank you, Mark. So since the dawn of the jet age, the gas turbine engine has improved by about 1% to 1.5% year over year. And we see a lot of runway for that to continue. The efficiency of a gas turbine engine is the product of the propulsive efficiency. That's really the fan, the bypass stream, and the nozzle, multiplied by the thermal efficiency. That's what happens in the core of the engine, where the stored energy in the fuel is liberated and turned into motion on a shaft. When we introduced the geared turbofan in 2016, we introduced a step change in propulsive efficiency. And we've continued to innovate on that. In fact, just last year, we introduced the GTF Advantage engine, which is yet another % more efficient than what was already flying. And so we see a lot of runway, and we continue to invest in those technologies. Today's engines are a bypass ratio of about 12 or 13, We've been working with NASA in the wind tunnels on bypass ratio 18, and we've even built an entire demonstration engine with the FAA under the CLEAN program at a bypass ratio of 15. So we see a lot of runway on propulsive efficiency. Similarly, the thermal efficiency in the core of the engine, we see huge opportunities. We see new classes of material systems that let us go to higher pressures and temperatures, embracing this higher efficiency. Ceramic matrix composites, and we at Pratt Whitney are investing almost $1 billion in Asheville, North Carolina, in a new manufacturing facility that's going to allow us to manufacture some of these even more advanced technologies at scale into the engine. Now, beyond that, we look to sustainable aviation fuel. We've been burning up to 100% SAF at Pratt Whitney for more than 15 years. And in fact, the GTF Advantage engine that I mentioned, through its certification process, we've already been running on 100% SAF since this past March. And so when it enters service in 2024, it will be capable of 100% SAF, regardless of what the standard is for that and specification is for that type of a fuel. Now, let's talk about electrification. In electrification, we see with the technologies that are available today, a sweet spot in the market. Starting with urban air mobility, which is enabled by about 0.5 megawatt to 1 megawatt to carry a few passengers, a few kilometers. Those technologies exist. If we take those same megawatt motors, drives, generators, distribution systems, and we combine them with a regional turboprop, Dash 8 100 is about 2,000 shaft horsepower. That's 2 megawatts. So you can do a 50-50 hybrid, and we with our Pratt Whitney Canada are developing that with de Havilland Aerospace and the Canadian government and the government of Quebec in partnership with a $163 million Canadian program. And that engine will be on the airplane and is scheduled to fly in 2024 with a capability of being 30% more efficient. On a single aisle, we can use those same components arranged a little bit differently. As I mentioned before, you've got the core of the engine and the low spool of the engine with the fan and the low pressure turbine. And by putting a motor starter generator on the core of the engine of order a megawatt and another motor generator on the low spool of the engine, we can now move power between the high spool and the low spool. And by doing that, we can re-optimize, re-envision the system, and that's worth about 5%. That's today without relying upon batteries or energy arbitrage. And as batteries get better, though, that 5% that's available there will improve even further. Now, we also are really excited about hydrogen. At first, we all thought hydrogen was going to be a challenge. While it does have 3 times the energy density on a mass basis, it takes up almost 4 times the volume. You have to store it on board the airplane as a cryogenic fluid, minus 253 degrees centigrade. When you burn it, if you're not careful, you produce higher oxides of nitrogen. And when you burn on an equivalent thrust basis, you're producing about 2.5 times more water. Water is a greenhouse gas, and contrails recently have been shown to be of equal global warming potential as CO2, even though they persist for much shorter times. So we've envisioned and are working actively on a hydrogen-powered gas turbine engine. We call it the high-side engine. It borrows from the technologies when we first ran hydrogen engines in the 1950s, and it reimagines that for the 21st century. We take advantage of the cold in the engine, we condense some of the water, and then inject it upstream. That mitigates some of the oxides of nitrogen. And we also use that in what we call an intercooled cycle. And by putting that water vapor in, it actually makes the engine much more powerful for the same size core, or you can shrink the core. When you cycle all that together, we envision the high-side engine, the hydrogen steam intercooled turbine engine, could be worth up to 35% more efficient than today's best geared turbofan. At Pratt & Whitney, we're really excited about the future. We don't know which technology will persist in terms of the infrastructure, but we do believe that it'll probably be a superposition, a combination of these. And we're really ready to be embracing the future. And as those infrastructures emerge, Pratt Whitney will be ready to power the aircraft of the future at scale.
Michael, thank you. That's a brilliant run through the options and also encompassing all of the work across the spectrum that Pratt & Whitney is doing. So that's the perspective of Michael, of Pratt & Whitney. You know, they must do this across this spectrum. But let's turn to an aircraft maker. I'm going to ask Joseph to come in here. You started on your hydrogen journey in 2006, and I do want, you are going to talk about something which just broke yesterday, a bit of news about, you know, what H2Fly, you know, who owns H2Fly, because, you know, we didn't know that. But, you know, Joseph, talk about your hydrogen journey and talk about a little bit about the Joby piece of news that came out. But welcome, Joseph. Please, you've got the floor.
Yeah, thank you very much, Mark. So maybe first of all, as German engineers, we do not talk too much. We do things and realize things. So H2Fly has been working since 2014, especially on demonstrating hydrogen electric aircraft. And we had a lot of success demonstrating that. And in 2021, when Joby approached us, we had not only the technology and the overview on how we could work very strongly together, but also a very good feeling that Joby and H2Fly share the same commitment to build, demonstrate, move forward, and really go into the market. So with that in mind, it felt very good to go together. I'm not going into the details on how we started that, but what I can say is we have a very strong relationship on a technological point, and we work together very strongly. So that is, let's say, the good news, very short time. But now the long-term very good news is that from our perspective, we started building a new conversion, so let's say energy conversion technology from like stationary applications, bus applications, car applications into the aviation application. And that was together with the German Aerospace Center, with the University of Ulm since 2007. And that experience since 2007 brought us to the point where we can say that hydrogen electric propulsion will have challenges regarding components, upscaling, and so on. But we do not see no-goes regarding the technology. And looking at the upscaling of the technology, we see also that there is a lot of work to do, but the components are not limited. Just in the upscaling step, to go now from our plane, which is around about 100 kilowatt, relies on automotive technology. And now going from there to 300, 500, 1 kilowatt or 1 megawatt, we see that we can improve from 2.5 kilowatts per kilogram on the stack level of the fuel cells, the core type of the fuel cell. We can improve to 4.2, 4.5 on the 300 kilowatt level. And we even can say we can improve to 7.1 kilowatt per kilogram at the megawatt level. And these are numbers based on technology which is already tested in the lab and in parallel as an architecture of the system is also tested in an aircraft environment. So with this in mind, what we see from a technology perspective, yes, there is a new era of hydrogen electric coming into town, and we have to invest, but the outcome would be that we have 80 degrees C, maybe 95 degrees C, doesn't matter, as a maximum temperature. So what we see there is that the contrail, even if we go into those areas higher than 10 kilometers, and we would expect contrails, the contrail shape and the density is different to what we see from gas turbines. Our first simulations show that the time where the contrails will be there are much smaller. So the contrails is gone, and the impact will be also smaller, even if we have more water there. We have 0 CO2 in the whole process of delivering energy, providing hydrogen, storing the hydrogen, and using the hydrogen. And that is at a very high efficiency in the whole chain, starting with the photovoltaics or wind going into the electrolyzer to get the hydrogen, to store the hydrogen, and then use the hydrogen. We are still, I would say, double as good as compared with synthetic air fuels coming from renewables and CO2 from the air. So that is a crucial point, because it gives us the energy, and from a technological perspective, it gives us the opportunity to develop new planes. And yes, it will cost now at the beginning some more money, but if we look at the complete system, energy delivery, energy storage, energy usage, and mission, which we would like to achieve, we can say we can be competitive definitely on the middle range up to like 4,000 kilometers. We stay a little bit more conservative and say 2030, 2,000 kilometers, 40 to 60, maybe 80 passengers. But with that in mind, we can go emission-free, and we can go with a very high efficiency on the whole energy chain. So having that in mind, I think H2Fly, just a little bit of publicity for H2Fly, I think starting now the commercial phase, it was a very important step, because 12 years of experience from the basics, from the system integration, from the process of developing technology in aviation, coupling that with the new energy conversion will lead us really to a change in aviation, how we know it today. And this makes me very optimistic.
Joseph, that's brilliant. And of course, the key thing is that you've built a demonstrator and you've flown it. I mean, how much has your demonstrator flown, just so we really know that you know what you've done?
So we have now more than 100 starts, so takeoffs in total with the latest one. So we had one before with the German Aerospace Center, but the 4-seater which we have today, that is the HY4, so hydrogen 4 for 4 people with hydrogen. That plane is made for a technology development unit. So behind those 100 takeoffs, there is a lot of ground testing and performance testing. And most importantly, in 2022, we started not only to look at the performance of the plane, but also to integrate the plane into a daily-like operation at an international airport in Stuttgart, how to deal with the hydrogen storage on ground, how to deal with the refueling, what kind of operational, let's say, rules and regulations we need to elaborate with the ground units, with the ground crews, and then to go flying, how we can integrate a plane into an airspace. So is that something special? Very basic questions. How to explain to the controller that this is a hydrogen plane and it has a little bit different procedures at takeoff and so on. But this is nothing voodoo. This is just work which has to be done. And I can say our flight test campaign will end now in June on the daily-like operation. And what we can say is definitely a plane with hydrogen electric can integrate into an airspace, into the ground environment. We can get refueling, we can get hydrogen on site. We need rules, we need to cope with those rules and so on, but it's possible, it's feasible. And maybe just one comment on this. I had a chance to fly with the internal combustion engine behind such a hydrogen plane. And I thought I give him a lot of space, so he has a plane of space so we do not get near to each other. And I tell you, it took me 20 minutes to catch up with the internal combustion, much more overpowered plane than with the electric plane. And this is something which you can feel the torque of an electric propulsion. So you can see really how this just climbs and climbs, very powerful. And then this is also very good because we can tell our engineers something is changing. So we are at the beginning of a change between using fuels like hydrocarbons, going to electric, and the same experience which we have on ground with the electric cars today. I can tell you it was the same feeling when I got lost behind that electric plane.
Very, very good. Great, great. Joseph, thank you so much. You know, this is somebody who's actually doing it. And I can sense this excitement amongst the engineers. I speak to a lot of engineers, but this is, you know, we're in the real world here. This is, you know, it's not just an engineer's loving, guys. Everybody, we're going to, you know, we've got people who want to operate and fly these aircraft. And this is what I want Andreas to talk to us about, because, you know, here we've got an airline that's ready. So Andreas, tell us what your story is at VDRO and what motivation do you have in pushing the zero emissions aircraft agenda, please?
Thank you, Mark. First, I just want to say to Joseph, I mean, I share your excitement, and I experienced flying only the small Pipistrel a few weeks ago, and that is an all-electric for those who don't know. And I was thinking about this as an electric plane until about 10 to 15 seconds on the runway. Then you forget, and then you find that it's actually more torquey, even better than any conventional plane I've flown. So I just wanted to tell that story. I know what you're saying, and I follow you 100%. But yeah, Mark, to your question, I mean, there are more reasons why we find motivation in pursuing these new technologies. And one is, of course, that even though you could argue that the transportation industry as a whole, and particularly the aviation industry, doesn't account for too much of the total global CO2 emissions. But still, we believe as an airline that our customers are the most important. And I believe that is a view that most businesses should share. And what we are seeing, especially in our part of the world, is that the customer cares more and more about this. And we also see that customers are looking at this in a very different perspective than we do as an industry normally. More and more people are looking at their personal CO2 balance sheet, if you like, and then they find that, okay, flying is actually accountable for a quite substantial part of their personal CO2 emissions. So when they start being concerned about this, we should listen. And that is one of the main reasons why we've decided to be so focused on this. Secondly, I believe, and that is to Michael's point at the beginning, there are so many new possibilities coming out from these new technologies. Michael mentioned eVTOLs. There are also perhaps an opportunity for small fixed wing planes to be allowed to fly in a different way than what we have been allowed to do so far. If we manage to decouple flying from pollution, we may be allowed to do more than what we've ever done before, and perhaps also expand the network and build new networks in a new way we haven't been in position to do before. So this is also about creating new business opportunities, not only to keep the existing customers we have. And thirdly, I mean, we are a Norwegian company, and the mother company of VDRO is operating a quite substantial network in Norway of short takeoff and landing fields around the country, where we are vital to connect all the small communities to the larger cities. Many of the flights we operate are quite short. They're all about connecting an island to mainland, crossing a fjord. Flights are down to 15 minutes. And for that reason, we believe we have a role to play as a test bed for new technologies, because we can make use of these technologies in the early phase of implementation. And that is why we decided, one of the reasons, together with the two others, why we decided to lean very much forward and say that we want to play a role, because we believe that these technologies being described so far will come first into the regional segment. So those are the three reasons why we decided to put this high up on our agenda.
Yeah, that's very clear, Andreas. Thank you. Just tell the viewers who you're working with, you know, because you've got a few collaborations, and I think it's just worth clarifying, if you wouldn't mind, Andreas.
Absolutely. I mean, we've been working for some time with Rolls-Royce on this, and also now we got Embraer on board on a study on how we can make a regional size zero emission aircraft for 2030. We've also been interacting a lot with Eve on the eVTOLs mentioned earlier here today, and maybe in the near future we are also now looking into a commuter class aircraft with Tecnam and Rolls-Royce, which may be ready for service even long before 2030. Of course, these new technologies comes with limitations, but to my point that our flights are quite short and also today operated with fairly small aircraft, we believe we can make use of the technology sooner than many other airlines.
Brilliant, Andreas, thank you. I'm going to ask Nikhil now to reflect and perhaps comment a bit on, what you've heard so far from our panelists, Nikhil. What's your take as somebody who observes and works in this space?
Thanks, Mark, and yeah, really, really interesting to hear already. I think the panel discussion here is really fantastic. You're really covering different parts of the value chain and different solutions that are coming into the market. I think what I'd like to point out is the enormity of the challenge. As a consultant, we have to really think about the entire ecosystem and the entire challenge really that's being faced by the aviation sector is really massive. So let me try to break that into two key aspects, which one is challenges which I do think are sufficiently in the public discourse, which is really, really good. But then the other is challenges which are insufficiently in the public discourse or really need to be focused upon more and more. So first, of course, we know decarbonization is key. We know hydrogen, sustainable aviation fuels, electric, hybrid electric, especially electric aircraft, or especially hybrid electric for narrow body scale and above, that could be compatible with sustainable fuels. I mean, these technologies will help decarbonize. These are the kinds of discussions that we already have a lot of, and we've started having that discussion already in this webinar today. But there's also challenges which are insufficiently in the public discourse, and that I would say is primarily the non-CO2 effects. And I was really glad to hear so much from Michael a moment ago on how Pratt Whitney is considering the NOx effects and how Pratt Whitney is considering the contrail effects. I think more broadly, the scientific understanding of these effects currently is low. So action today comes down to people like Michael and his team genuinely thinking ahead and doing their best as ultimately engineers to solve a solution that most people aren't even talking about. When you look at things like the European ETS, well, they don't charge for contrails and for NOx today. In fact, it would be really difficult to do so, even if the intent was there, just because we don't know how bad these effects are. But the interesting thing is that taking a step back, even if we don't fully understand the depth of the effects or the size of the effects, actually the solutions are often much more achievable, such as flying a little bit differently could have a major impact on contrails. So tying it all together, ultimately it comes down, strangely enough, to cost. Here we are talking about exciting new technologies, scientific effects which are currently beyond us, but being looked at. What we have to recognize is this: in this amazing industry, we've had this democratization of travel over the past many decades, enabled by the technologies that we have, to be honest, come to take for granted today. You can jump on a plane and get from one part of the world to the other in a very, very small wallet share. It's really a fantastic achievement that we, as an industry, have to congratulate ourselves for. So the question is it possible for us to make this transition to sustainability without scuppering this achievement? How can we do it in a cost-effective way? And it's extremely exciting to hear from Joseph that that they've worked out the competitiveness of their hydrogen aircraft up to 40 to 80 passengers, up to 2,000 to 4,000 kilometers. That's really fantastic. But it's really the entire ecosystem that we need to worry about. If we're looking at hydrogen, we'll need electrolysis capacity. However, we have to recognize that a lot of other industries also need hydrogen. So aviation is not going to be first in line. Let's be clear. There are industries that need hydrogen more than aviation will. And when we get to larger aircraft, we'll probably need to liquefy that hydrogen, which aviation will most likely have to pay for because other industries won't need it. If we're looking at sustainable fuels, again, we need production capacity. And if we're moving to power to liquid, which is the best type, the most sustainable fuel, then we'll probably need DACs, or at the very least CCS capacity, capturing carbon from point sources, which is very, very expensive today. So we need all of this innovation that we're talking about, and we need it in every part of the value chain. And that's the biggest challenge that I think is kind of left on the table today, where we talk a lot about new aircraft. Awesome. We talk a lot about new technologies, fantastic, but it's the entire depth of the supply chain. It's the entire depth of the aviation value chain that needs that innovation to happen.
Well, Nico, great. You covered a lot of areas there. I'm going to ask Joseph to respond. I can see you want to respond. Why don't you kick off, and then I'm going to go to Michael to talk. We'll talk again on pursuing the hydrogen option as a technology to some of your points, Nikhil. Joseph, come in on and reply a little bit to some of Nikhil's points, if you would.
I think, Nikhil, you are completely focused and on the right path to do this. I think, and this is my personal opinion as an engineer, but also as a human being on this planet, we do not have 50 years from now to do business as usual, or every second year we have 1% less, and so on and so on. So if we really want to do a change, we have to do it in the next 20 years. And that's up in that time, we have to change it. So you mentioned that having renewable energy, nobody will ask us if we want to have in aviation renewable energy. And this is what we have to open up. We have to look at the system which delivers the renewable energy, which combines it with the fuel, with the highest efficient fuel which we can get, and then combine that with the use of that fuel at the highest efficiency. And why I'm pointing out this highest efficiency is because the numbers on the absolute scale which we need to get this mission done are so huge that every difference, even a couple of points of efficiency, which are less with the synthetic air fuel, will lead to a tremendous increase in investments on the renewable side. And we have done the calculations for Europe, and we will need for the hydrogen plane development, storage, renewable power, provision, electrolyzer, everything around. We will need 300 billion for the next 20 years. But if we go with the SAF path for Europe, we will need 800 billion. So due to the big numbers of energy which we need, every change in the energy efficiency leads to huge investment numbers on the financial side if we want to do the change in the next 20 years. So we have, as aviators, to bring our energy source, our storage, and our usage with the right technology. If we want to do it in the next 100 years, let's go hydrocarbons. Let's do a little bit of SAF here, a little bit of SAF there, stay with fossil hydrocarbons, and let's go. But this is not what we want to do. At least myself, I'm fighting to change this.
Joseph, thank you. Michael, come in on a thought there, because this is what the numbers are just so staggering. It kind of almost overwhelms you. But what's your view?
Now let's put the amount of energy in a question on the table, and let's talk about it in that context. And then I'll close by looping back to the efficiency that Joseph was referring to. The commercial fleet in 2019 burned about 100 billion gallons of fuel. And that number continues to grow post-COVID at about 4.5% year over year. Now, when you think about that in terms of equivalent energy, that's about 600 gigawatts. 600 gigawatts represents on an electrified basis about 15% of the world's generating capacity. Hydrogen, there were some questions in the chat about how much hydrogen is there. So if you look at the world production in 2019 of hydrogen, and I used 90% of that for aviation, you'd power 10% of the commercial fleet. And oh, by the way, with SAF, we never want to compete with food sources to make sustainable aviation fuels. Most of that hydrogen today is actually used for fertilizer to make ammonia, which goes to feeding the planet, and there's not enough food today to feed everybody on planet Earth. So 600 gigawatts, 15% of the world's generating capacity. And oh, by the way, if you need to introduce that, you need to introduce that with renewable sources. So let's talk about the world's generating capacity at this very moment. We recognize that there are places, for instance, in Andres' home country, where it's largely electricity is produced by renewable sources. But it turns out, let's think about efficiency now, as Joseph brought up. When you compare it to a regional turboprop, those engines are about 30 to 35% efficient. When you look at a geared turbofan flying a cruise, you're at 50 to 55% efficient. That's 10 to 15% fewer grams of CO2 on a kilowatt hour basis than the world's electrical grid. So today's engines, with the efficiency we have, are actually doing better than the electrification until the grid can catch up, until the infrastructure can catch up. It's really going to be a significant challenge. And when you look to hydrogen, if we only want to use green hydrogen from renewable electrical sources, the challenge is staggering on an infrastructure basis.
So that kind of begs the question to me, Michael, about if it, you know, for a 100-seater plus airliner hydrogen, why are we bothering at the moment? Because it's technologically no doubt feasible, but the cost of the energy, etc., just seems to be beyond sort of comprehension.
So as I mentioned earlier, at first we looked at all the daunting challenges associated with hydrogen, the storage, the higher production of oxides of nitrogen, the water and the contrails. And at first we thought that was enough to think was maybe not such a great idea. We're moving beyond that now. And we see as engineers, maybe there's an opportunity to reimagine what the system looks like. And that's when we come to our high side engine. When we look at our smaller, as we see these things, particularly in markets such as where Widerøe flies, where you have short hops from island to island or across a fjord, there might be opportunities on the early time frame. And so, as I mentioned previously, we see a superposition of solutions here. So, for example, I described the regional turboprop, which was half electric and half a gas generator. There could be a future, if there's hydrogen available on the flight line in certain locations, that gas generator does get replaced. A less efficient gas generator could get replaced with a new reimagined, say, fuel cell. And now you have the electrical powertrain, and you can take advantage of that with either a gas generator or a fuel cell as the optimal system instantiation. It comes down to where the costs are, as was said previously, and introducing these technologies at scale in a cost-effective manner where you get over the hurdle rate for investment to learn it out and then to have it fully embraced from an infrastructure standpoint.
Thank you, Michael. But is it really realistic for a 100-seater aircraft or more in the 2035 timeframe? I know it's a difficult question and you get asked all the time, but I think it's a valid one because it just feels very soon.
The next, we don't know when the next single aisle aircraft is going to be produced, and we work very closely with our airframe partners and customers, and we talk to them on an ongoing basis. And we will be ready with the right technologies in the right time. For the next generation, if it is introduced sometime in the middle of the next decade, it's likely to embrace some of the technologies. For example, we do believe that electrification could find its way in if the aircraft is architected to accommodate that with the right high voltage distributions and so on and so forth, we'll be ready with those technologies. For hydrogen to be ready and available at the flight line at scale anywhere on the planet, probably going to be a little bit further out.
Mm. Oh no, thank you for your candor, Michael. Appreciate that. And you know, Joseph, what's your sort of take here? Because you know, you nobody's mastered the technology yet. Well, you're starting to at the smaller scale. Where can it go for you? And when would you, you know, maybe with your new connections, etc. But when would you think a hydrogen product, an aircraft that's actually a product that could be delivered, might be in service?
So I think we have to differentiate a little bit between which kind of plane we are aiming for. So let's say we are aiming for like a fixed wing aircraft, 40-seater, Dornier 328 like, something like over 1 point something megawatt on each side. Then I think with the right upscaling capabilities, and then I'm not talking about new physics, I'm talking just developing new components, implementing those components, and then qualifying those components in the, let's say, very conservative aircraft like a Dornier 328. I think we have a really good chance to go in a first flight in 2025-26, and then in 2030, with the right environment, I am very confident, based on the technology which we see today, that we can have the first product. And
how large would that product be, Joseph? Just what would it be? 4-seater, 6-seater?
That is something in the region of 40 in the megawatt scale propulsion system.
Right. Andreas, what's your thought? Are you going to put a LOI down in the next, you know, Joseph's got something that he reckons there for you?
Well, we're always curious to hear about new concepts, for sure. Another aspect of this, and I think it's important to bring that into the conversation. I mean, there are differences around the world when it comes to accessibility of renewable sources, for instance. I mentioned 3 reasons why we decided to lean forward. Maybe there is a fourth. As already pointed out, I mean, 99% of all electricity in Norway is renewable, from renewable sources. We actually have more energy than we need, so we're exporting now about 10 to 15% to the UK through cables across the North Sea. So I believe it's also important to understand different markets' need. But of course, I do also understand Michael's view that many places in the world there will be lack of renewable energy, and there are many reasons why this may be a challenge. But some markets will be ready sooner than others, and I think that is also an important part. Question remains whether we can build that market big enough to scale this quick enough so that Joseph and others in his part of this business can get these products at scale as soon as he wishes to.
Michael, scale. What's your thought on scale? Obviously, you've got the work that's going on with Pratt Whitney Canada. Just talk about that in terms of, you know, that's a hybrid, obviously, solution, electric hybrid. What's your thought on timing there and scaling that up?
So that technology, so we're in the process of the details of putting that engine together. Our first flight is on track for 2024. So we're moving forward very aggressively, and we're really excited about the technology. The motors, the drives, the generators, the distribution systems, they're all under development with our sister division, Collins Aerospace, part of Raytheon Technologies. And so we're working closely with them to integrate these, because the integration is such a critical factor. We're also learning a tremendous amount about how does one go about safety, handling these types of scenarios, failure modes, and ultimately the certification procedures that are going to be needed to embrace this. When you think about certification processes, these types of engines are going to change the boundaries of where the chapters that are used for certification will matter. So this early learning will be really, really valuable and important. In terms of moving forward, we're continuing to work on larger motors, drives, generators, so the technologies are moving forward. That's true across the industry. But when you think about a single aisle, right, you're talking about 18 megawatts to 20 megawatts on each side of the airplane, okay? So you're talking about an order of magnitude more to do a single aisle. And that scaling is just going to take us a little bit longer as a society, as an industry, to really embrace. So unless you envision a complete change in the demographics of the today's airline model, and in terms of hubs and spokes and point to point, the only way that those technologies will be ready in the near term to get, say, 20 megawatts at flight capable power densities, it's going to take some time. But the beauty is those same technologies that I mentioned earlier, you can combine them, re-optimize a hybrid system, and there's value there today. Right? As I mentioned, 5% just by introducing about 1 megawatt on that base 18 megawatts. And as I also mentioned, as the batteries get better, there'll be more opportunity. One last point, and Joseph sort of alluded to this, gas turbine engines or combustion engines tend to lapse with altitude, right? As you go higher in altitude, the amount of power you get out of an engine goes down. Electric motors don't experience that. And that's why some of the pilot experience that Joseph was describing and that Andres was describing, that particularly at altitude, that you have that persistence of power, it also changes perhaps the way the entire air transport system might be reimagined for the future.
Michael, thank you. Nikhil, what's your sort of take here, listening to this section here?
Yeah, no, this part of conversation is really bringing to my mind one of the key areas which may differ for us as passengers going forward, right? So today, we live in a world in which we have a mix between airlines doing the classic hub and spoke, right? So you look at your legacy carriers, you look at your Emirates and your BAs, where they have their massive hubs and their giant aircraft, you know, hundreds and hundreds of passengers on these planes, and they carry them between these hubs. And then you do have their feeder flights from all over their network to actually feed these hubs, like a Heathrow or a Charles de Gaulle or whatever it happens to be. But then you have some other airlines as well who operate point to point. These are the you know, classic names that you've heard of as well: Ryanair, EasyJet, Widerøe to a large extent, and they're really serving a different scale of airport. What we're talking about with this revolution is maybe having to push the point to point business model even one step further. Not looking at tier A to tier A airports or tier B to tier B airports, but maybe tier C to tier C airports. The airports that today you might just be able to fly, you know, general aviation hobby flights out of, they could become tomorrow's genuinely commercial aircraft ports, right? And if we're talking about 40-seat aircraft being available by 2035, this is a massive, massive change. Today, airline business models and the cost structures that we're all used to are entirely a function of the economies of scale that you can get with hundreds and hundreds of passengers on these planes. If you reduce that number down to 40, you need a different business model to make it possible without completely destroying the wallets of your passengers. And that's not something any of us wants, right? So we need to rethink that. And there's a big challenge.
Can I ask you? I'm just going to ask Andreas to come in on that point, because he's going to give him some thumbs up and stuff, and giving high fives to you there. So Andreas, I'll come back to you, Nikhil. But Andreas, what you know, why are you enthusiastic?
I couldn't agree more, and I mean, this is probably the main reason why we decided to create a new company, because what we learned through our work for a long time now with Rolls-Royce and partners and so on is that, I mean, these new technologies comes with many opportunities, but also some constraints, and you cannot really expect them to fit directly into your existing business model. And if they could work in your business model, it may be so that you make more out of them if you are willing to also change your business model and adapt to the new technologies. So I think this is really a question about how can we make and design the best business model when we look at the new technology being out there in the coming years, and we try to understand what the customer really wants. And I don't think he wants to fly zigzag hub and spoke if he can go direct. And then try to derive a business model which makes the best use of technology to fulfill customer expectations. So I couldn't agree more. And that pretty much is the very reason why we decided that it is necessary for us as an airline to be willing to think afresh and really start with clean sheets when we want to make the best use of new technologies.
Yes. But Andres as well, it's totally interesting. So different business models, which is why you form a separate business, so you're not constrained by your convention. But do you think there might even be the case at some point where if you don't have a very low emissions or as near zero emissions aircraft, you won't be able to fly to some places because they will not allow you in? A bit like noise, when, you know, chapter whatever it came in. No, if you're chapter 2, 3, whatever, you can't come.
I mean, that could certainly be, and that may also be different from one market to another market, one region to another region. But I'm pretty confident that you will benefit massively if you can operate with zero emission and also perhaps less noise. You will be allowed to fly in the future places that others can't. I believe it's going to help enormously for us in our pursuit for building more business, more mobility services in Norway and around, if we can get to zero emissions and less noise.
Nico, did you want to finish off your point? Because obviously I cut you off, which is my privilege as the moderator. But did you want to finish that off?
I'll just say a few final things. I think the model that Widerøe Zero is following is a really inspiring one, right? Because of the reason that you actually pointed out, Mark. It's stepping away from existing conventions that we have to be able to do, and to do that you need new business models. But I would add a few other new ways of thinking that we need to bring to bear. What Andreas and his team are doing is really within an airline. So new business models within an airline. I'm going to go broader, looking at the entire ecosystem, just to name a few other types of business models that might be required. One which is essential, I think, to really understand and extract the best out of is vertical integration. What we look at historically, when you look at any new trends that come out, you know, when Thomas Edison invented the light bulb, he had to invent the entire electrical grid to be able to sell his light bulb. There was no electrical grid for people to power their homes to be able to use his light bulb. So he had to create the rest of the value chain. Now, what does that really mean? What that means is when we think of new technologies, we shouldn't assume that they just slot in like a perfect puzzle piece into the ecosystem. They don't. Maybe it's a new puzzle that you need to start. And sometimes that needs vertical integration. That's one aspect. Another aspect is new funding models. We live in a really fast moving world where, you know, returns are expected in 2 or 3 years. That doesn't really work in this industry, and we know that doesn't work. We need much more patient capital, and that's a really rare thing with long-term return expectations. Very rare, and we'll need trillions. By the way, this is, I mean, Joseph talked about hundreds of billions for Europe. We're talking about a global industry at the end of the day, and this is trillions that we will need, which is not forthcoming today, and investor expectations are not aligned. And the final thing I'll mention, which is also a new business model, new way of thinking about it, and might actually help with my second point on funding here, is how governments think about taxation, and about how governments think about all the various charges. Now, earlier we spoke about cost. Today, a passenger has to pay air passenger duty. That's what we call it in the UK, but it's basically a departure tax. In Europe, you have to pay the ETS, right? And in some countries, you actually do have to pay some form of kerosene tax as well. It's rare. It's not really common between major economies, but it does exist. Now, all of these taxes are typically money being funneled out of aviation. Even with the ETS, even though a lot of that money is reinvested back into decarbonizing, it's not typically
Nikhil, give me 30
aviation.
seconds and I'm going to run around everybody.
Perfect. And ideally, in an ideal world, we would actually see all this taxation being put back into the industry to accelerate the development of these new technologies, the certification of these new technologies, and the development of all of the infrastructure that's required. The government is very well placed to do that. So those are just some of the additional business models that I think we might need. And I'll stop there and hand over to the others.
No, I think this is why this is such a big space. It's about technology, yes, but it's so many elements to it. Andreas, a last word from you, just in terms of your crystal ball. Where do you want to be 5 years? What's your sort of timeline? Just give me 30 seconds, please.
Well, our aim is to see the first zero-emission small commuter aircraft available in Norway this side of 2030, so from 2025 to 2030, and hopefully a regional size aircraft around 2030. And from what I've heard so far, that aligns pretty much with the technology expectations thrown out here today. So I hope it's a goal we can reach.
Great, Andreas, thank you so much. Joseph.
Yeah, so maybe I finish with a personal experience. During Corona time, I had the chance to use a private plane to fly around Europe and do my meetings. And this is a major driver, which I think will cope with the needs which we have in the future. And that is, we have low noise aircraft, which can fly into diversified airports. And the convenience of stepping into an aircraft in 5 minutes, taking off, going to your place and being there, coming back, take the plane and go home, that is so powerful. If we can have smart technology, the clean technology, and the low noise technology with the electric, which hydrogen electric promises for all of those. The pressure from a market perspective, we have to do it cheap, we have to do it convenient, and we see that with the technology which we have today, we can do it. So I'm very optimistic the market will go into that, and we have to do it as engineers and businessmen.
Joseph, thank you very much. I'm going to give the last word to Michael Winter. Michael, you're hell bent on this whole area, but what's your sort of summation here?
I'll offer a bit of a contrast then to what Joseph said. At Pratt Whitney, we provide propulsion safe and reliable at scale on a global basis. So let's think about the infrastructure. Today, the world spends close to $1 trillion to $1.5 trillion on capital expenditures for oil, gas, pipeline, drilling, electrical generation, distribution. It's on the order of $1.5 trillion a year between those two industries. Right? And when you think about the next 28 years till we get to 2050, that's about $45 trillion. It's all going to be spent on something. And so we have an opportunity. And to Nikhil's point, that reinvesting in our industry through public-private partnerships will become enabling to look at these technologies. We're really excited about the technologies, starting with the gas turbine engine, moving through sustainable aviation fuels, embracing electrification, and ultimately for hydrogen. That infrastructure will emerge, and working across the industry and working specifically for Pratt & Whitney, we're going to develop those technologies, and as a company, we'll be ready to continue to provide propulsion safe and reliable at scale.
Michael, thank you. And I think we've really encapsulated what a massive topic this is, but the excitement, the passion, but the entrepreneurs, the pioneering work that all of you are doing, and many others, is going to continue. We're going to be talking about this all through this decade. I'm sure the discussion in even 2 years' time will be quite different from the discussion we're having today. and we'll have a lot more technology on the shelf and, you know, or ready to come off the shelf to deliver some really, you know, low emissions, even zero emissions aircraft and products. Thank you, everybody. Thank you, Michael. Thank you, Andreas, Nikhil, Joseph. Thank you to the audience. I think we've got most of your questions. There's some very detailed ones which I didn't want to get distracted with, but thank you. Thank you to our sponsor, Pratt Whitney. This webinar will be on demand shortly. Our next aviation one, sustainability one, is set for later this year, probably in September. So do look out for that. Do look out for all of these people, all of their companies as they develop, because they are really doing some groundbreaking things in this area. I thank you all very much, and I wish you a very good day and goodbye until the next time. Thank you, everybody.